All right, let's set the scene. You're on a team. You need a new piece of software, maybe a new capability. It could be a completely new system, to run part of your business. And immediately you're faced with this pretty fundamental question, one that has enormous implications, really, not just for your tech stack, but for your budget, your timelines, even where you focus your most valuable people. Do you build this thing entirely from scratch? Do you go out and buy an existing solution sort of off the digital shelf? Or do you leverage one of these increasingly powerful platforms that let you configure something using visual tools, maybe with very little or even, no traditional coding? Yeah,
Mhm.
this isn't just a simple technical choice anymore. It feels like it's become a core strategic decision. Well, virtually every organization in 2025.
Yeah.
And it's exactly what we are diving into today. Our source material for this deep dive is a really crucial report titled Build, Buy, or Configure Software Strategy in 2025.
Self-defense.
Pretty straightforward. We want to cut through the complexity, right? All the overwhelming options, sometimes even the dogma surrounding these choices. We're going to try and extract the absolute most important insights from this report, hopefully helping you understand the strategic calculus and maybe figure out where your team's precious engineering time, those resources, are best spent, both now and, looking ahead.
And that question, where to spend engineering time, it's just more critical than ever because the whole landscape has, well, it's fundamentally changed. If you think back maybe decades ago, custom code was often the only real option. If you needed software, you built it, full stop. But the report makes it crystal clear that in 2025, that's just one path among several. You've got the rise of robust SaaS tools,
Mm.
easy to integrate APIs, application programming interfaces, the things that let different software talk to each other, and these sophisticated no-code, low-code platforms. All this means teams have really powerful alternatives now. So understanding the strategic implications, the trade-offs between building something truly unique versus leveraging existing proven components, that's paramount. It's really about making informed, deliberate decisions, not just, defaulting to the old ways.
Exactly. And whether you're an engineer actually, building software day to day, or maybe a project manager trying to define scope and timelines, a product owner prioritizing features, maybe someone in a business role just needing a tech solution to a problem, this deep dive is really designed to give you a shortcut. A way to get deeply informed on this critical strategic decision point. We're going to unpack the report's view on the pros, the cons, the hidden costs, and maybe crucially, how the smartest, most effective teams are navigating this landscape right now. Okay, so let's start by maybe clearly defining the playing field. The report lays out these three core paths, right? These distinct approaches you can take when you need new software functionality. They are, well, as the title suggests, custom code, SaaS tools, and no-code, low-code platforms.
That's the foundational breakdown the report uses, yeah.
Yeah.
And it's really important to get a clear handle on each one distinctly before we start thinking about how they might, interact or combine.
Okay, path one. Custom code. This is the one probably most familiar, I guess, to traditional software development teams.
Yes, absolutely. This is building software entirely from the ground up. Your team is responsible for writing pretty much every line of code, designing the architecture, setting up the infrastructure,
Oh,
everything. You're starting with programming languages, frameworks, maybe databases, and building a solution that's specifically tailored to your needs.
and the core concept here, which the report really seems to emphasize, is full control, full responsibility. You dictate everything, but yeah, you also own everything, the good and the bad.
Exactly. And like we said, historically, this was the default. But in 2025, the report positions it as a deliberate choice, one you make for specific strategic reasons. According to the source, the ideal use cases for this path are things like IP-heavy systems, meaning the software itself is your core intellectual property, or maybe it's the source of your unique competitive advantage. It's also often necessary for really deep, complex integrations, maybe with existing internal systems that no off-the-shelf tool could easily handle, or for highly specific workflows that are just truly unique to your business processes, things that simply wouldn't fit into a standardized solution from a vendor.
Got it. So build it when it's your kind of unique secret sauce, or maybe when your operational spaghetti is so tangled that only a custom solution could possibly connect all the pieces. Okay. Path two is SaaS tools, software as a service.
This represents the buy option. So instead of building, you're essentially purchasing access to a ready-made software application, one that a vendor develops, hosts, maintains, and updates for you. You typically access it over the internet, usually through a web browser or maybe a dedicated app.
And the core concept for SaaS, as the report puts it, fast, proven solutions for common business needs.
Precisely. And just think about how ubiquitous SaaS is today. Examples are absolutely everywhere. CRM systems like Salesforce or HubSpot for managing customer relationships. Billing and invoicing software like Stripe or Square are often bundled with payment processing, but SaaS at their core. Communication platforms like Slack or Zoom, or maybe dedicated authentication services like Auth or Okta that handle user logins and security. The report correctly points out the big advantage of low upfront cost. You usually pay a subscription fee, maybe monthly or annually, instead of that massive initial development investment. You get a functional system almost immediately. However, the inherent trade-off, compared to building, is a limitation in flexibility and customization. You're adopting an existing system and, well, it's a defined way of working.
Makes perfect sense.
Mm.
You buy something when the problem you're trying to solve is, well, a common one, something many other businesses also face and for which good solutions already exist. Okay, and path 3, no-code, low-code platforms. This is where things start to feel a bit newer, maybe a bit different for many traditional organizations.
Oh, it's certainly gained significant traction in recent years, yeah.
Yeah.
This path involves using tools that allow individuals, often people without deep traditional software engineering backgrounds, to build functional applications. They primarily use visual interfaces. Think drag and drop components, drawing connections between data sources, configuring logic using graphical workflows, all with minimal or sometimes no traditional coding involved. Low code might involve a bit of scripting or light coding for more complex tasks, whereas no code really aims for zero traditional code.
Yeah, the immediate appeal here, the report says, is that it enables business-led development.
That's the core concept, and it's potentially transformative. These platforms empower people who are closest to the business problems teams in marketing, sales, operations, HR, to build specific tools to solve those problems themselves. They don't have to write code, and, importantly, they potentially don't have to wait in line for overloaded central engineering teams. It sort of democratizes software creation. The report notes these platforms are particularly great for rapid prototyping, building internal tools tailored to specific departmental needs, or enabling citizen developers and individuals using these tools to automate tasks or create applications for their own or their team's use. The report is also careful to clarify, though, that while powerful, these platforms have a distinct set of capabilities and limitations compared to the other two paths. They're not a universal replacement for traditional engineering, but rather a different kind of tool in the arsenal.
Right, so it's not necessarily intended to build the next, Google search, but it could build the system your marketing team uses to track campaign requests internally.
Exactly. It really fills a gap between, say, rigid off-the-shelf software and complex custom development.
So the initial takeaway from the source report right at the outset really hammers home the complexity of this choice. It says, each approach has strategic advantages and dangerous blind spots. It immediately tells you, look, there's no single right answer for every problem, and making the wrong choice can lead to significant issues down the line. This isn't a one-time easy decision. It definitely requires careful consideration. Okay, let's really deep dive into that first path, now building it yourself with custom code. The report labels this section Freedom and Friction. What does this report tell us specifically about the benefits you gain and maybe the challenges you face when you choose to build?
Well, the report lists several clear and pretty compelling advantages to custom coding. These represent that freedom part.
Yeah, it mentions things like full control over UX, logic, and architecture, no vendor lock-in, and that it's ideal for proprietary systems.
And these aren't just abstract terms, right? They translate into significant strategic power. Let's unpack full control for a second. When you build from scratch, you dictate everything. Every single pixel the user sees, that's the UX, the user experience, every step of the underlying business logic, and the entire technical foundation, how data is stored, how different parts of the system talk to each other, what tech is used, how it scales. This level of control is just indispensable when your business has truly unique needs or requires incredibly fine-tuned performance or needs to integrate really deeply into complex, maybe legacy internal systems. You have the power to make the software exactly match your requirements without compromise.
And that no vendor lock-in point, that feels like a massive strategic advantage that shouldn't be underestimated.
Oh, it really is. When you build it yourself, you are not dependent on some third-party company for the core functionality. You don't have to worry about a vendor suddenly changing their pricing model, which, as we'll see, can be a huge problem with SaaS. Or maybe them going out of business, deciding to stop supporting a feature you rely on, or making updates that break your workflows. You are entirely in charge of the software's destiny. The flip side, of course, is that implicit in that freedom from a vendor is the responsibility to maintain, update, and secure it yourself, basically forever.
Right. You trade dependence on a vendor for a complete self-reliance.
Okay.
And the ideal for proprietary systems point seems to solidify when this path is most compelling.
Absolutely. If your business's core competitive advantage, your unique value proposition, the software itself, maybe it's a cutting-edge AI algorithm, a revolutionary data analysis platform, a proprietary trading system, or, I don't know, a patented user interaction model, then building that core differentiator yourself is almost always the right strategic move. That's your intellectual property, your strategic moat, as the report calls it. Something that's hard for competitors to copy quickly. You wouldn't want to hand over the keys to your core innovation to a third-party provider if you could possibly avoid it.
Okay, so that's the freedom side, the strategic upsides of building. What about the friction? The report lists the significant cons: slower to build and maintain, higher initial cost, and requires top-tier engineering talent.
Yeah, these are the hurdles, and they are substantial. Slower to build and maintain is maybe the most obvious one. When you build from scratch, you often have to build not just the unique differentiating parts, but also many foundational components that are common across software applications. Things like user account management, role-based permissions, basic data storage mechanisms, security protocols, integrations with common email or messaging services. Much of this, let's call it boilerplate functionality, already exists in SaaS or no-code tools. Building it yourself adds significant time to the initial development phase compared to just adopting an existing tool. And crucially, maintenance is an ongoing, often underestimated cost. Bug fixes, security patching, adapting to new OS versions, managing the underlying infrastructure, adding new features, all of that falls squarely on your internal team indefinitely.
Which directly translates into that higher initial cost, I imagine.
Precisely. The extensive time and engineering effort required for a ground-up build demands significant financial investment upfront. You're paying for a team of skilled engineers for potentially a long period before you even have a functional product. And, importantly, this isn't a one-time cost. The ongoing maintenance and evolution costs are also substantial over the software's lifetime.
And you can't just hire anyone to build these complex, mission-critical systems, right?
Exactly. This is where it requires top-tier engineering talent comes in. Designing, building, securing, and maintaining large-scale, robust, performant custom software systems. It's a highly complex undertaking. It typically requires experienced software architects to design the overall system, senior engineers for the critical components, and skilled developers for implementation and ongoing work. This level of talent is not only expensive, but also highly competitive to recruit and retain. Attempting a complex custom build with an inexperienced team is, well, often a path to project delays, cost overruns, and ultimately a system that's unstable or incredibly difficult to maintain.
The report gives a great example here, doesn't it? A fintech company that built its core transaction engine from scratch.
Yes, that's a perfect case study. It illustrates exactly when building is strategically necessary and really pays off. The report highlights the specific reasons why they chose this path. They needed to optimize latency, the speed transactions are processed, which is absolutely critical in high-frequency finance. Milliseconds matter. They also needed to handle incredibly complex and constantly evolving regulatory requirements specific to their financial niche. An off-the-shelf system, while maybe faster to adopt initially, simply wouldn't offer the granular control needed for that kind of performance tuning, or the flexibility to rapidly adapt to new compliance mandates unique to their business.
And the outcome, according to the report, was fascinating. This custom engine became both a strategic moat and a hiring magnet.
Isn't that interesting? It wasn't just a necessary cost center. The custom-built core became a powerful competitive advantage, something difficult for competitors to replicate quickly or cheaply. It created a defensible position in the market, and perhaps counterintuitively, it helped them attract talent. Top engineers who are passionate about working on challenging, high-impact core business systems were drawn to the opportunity. It actually made it easier for the company to build a high-performing team.
That example really drives home when building is the clear strategic winner, when the software isn't just supporting your business, but is your business's unique differentiator, its core engine.
Absolutely. Which brings us directly to the report's concise takeaway for this custom code section. Build when differentiation matters. Don't reinvent commodity functions.
Right. Like, don't spend your engineering time building your own email marketing center if you're, say, an e-commerce store, but do build your unique product recommendation algorithm if that's what sets you apart.
Precisely. Focus your most valuable resources, your top engineering talent, and their limited time on solving problems that are unique to you and provide that competitive edge. Don't spend months building a standard login system or a basic admin panel. If secure, robust, proven solutions already exist for those problems as SaaS or platforms, that's just reinventing the wheel, and then you're stuck maintaining that wheel yourself forever, diverting resources from where they could create real, unique value.
Okay, so building is reserved for when your software is the secret sauce, the truly unique differentiator. But what about when when it's not? When you need something functional, reliable, and fast for a common business task that doesn't give you a unique competitive edge, here's where buying or using SaaS enters the picture. The report talks about speed, scalability, and constraints in this context.
Yes, and for these non-core functions, SaaS has become incredibly dominant, and frankly, for good reason. The advantages it offers are very compelling in the right situation.
The report lists the key pros of using SaaS. Proven solutions with ongoing updates, quick to integrate, and scalable and secure generally. Let's unpack those.
Okay, proven solutions with ongoing updates is a major win. When you adopt a mature SaaS product, you're leveraging software that's already being used by potentially thousands, maybe millions of other customers. This means it's likely well-tested, relatively bug-free, and the vendor is continuously investing in improving it, adding features, enhancing performance, fixing issues. You get the benefit of all that ongoing R&D and maintenance without having to lift a finger yourself, essentially. The vendor handles the hard work of keeping the software current and reliable.
Yeah, that offloads a tremendous amount of work from your internal team.
It really does. And it directly contributes to the next pro, quick to integrate. SaaS tools are designed for rapid adoption. They typically have well-documented APIs that make connecting them to other systems relatively straightforward, user-friendly interfaces for configuration, and often standard connectors for popular third-party services. Getting a SaaS tool up and running and actually delivering value is often orders of magnitude faster than building equivalent functionality from scratch.
Speed to value. That's a core benefit right there.
Absolutely. And then scalable and secure. Reputable SaaS vendors build their platforms to handle large numbers of users and high volumes of data. They invest heavily in the underlying infrastructure to ensure the service remains available and performant as usage grows. They also typically have dedicated security teams and processes, investing far more in security measures and compliance certifications than most individual companies could afford for their non-core systems. While, you still have a responsibility to configure the service securely and manage user access, they handle much of the fundamental security burden at the platform level.
Okay, so speed, proven reliability, security, those are clear benefits. But what are the downsides? The constraints, as the report puts it. It lists the cons as limited customization, vendor risk and lock-in, and data ownership and compliance questions.
Right, limited customization is the most direct trade-off for getting that proven, ready-made solution quickly. SaaS products are built to serve a broad market, so they offer configuration options, maybe some workflow customization, API access, but you are fundamentally constrained by the features and architecture the vendor provides. If your business process deviates significantly from the standard workflow the SaaS tool is designed for, you usually have two choices. Adapt your internal process to fit the software, which can be disruptive, or accept that the tool won't perfectly meet your needs. You just don't have the freedom to customize every detail like you would with custom code.
And then there's the point where it gets really strategic and potentially quite painful vendor risk and lock-in.
Ah, yes, this is critical, and it's where many organizations get into trouble if they don't think ahead properly. When you deeply integrate a SaaS tool into your operations, especially if it handles critical business data or workflows, you become dependent on that vendor. What happens if the vendor suddenly announces a massive price increase that makes the service unaffordable? What if their quality of service degrades, or they experience frequent outages? What if they get acquired by a competitor you don't want to do business with? Or worse, they go out of business entirely. Because your data and processes are now tied up in their system, switching to a different vendor or trying to replace the functionality with a custom build can be incredibly difficult, expensive, and disruptive. This difficulty in switching is vendor lock-in. The pain isn't usually in signing up. It's in the potential future pain of trying to exit or facing really unfavorable terms.
Yeah, it's kind of like renting versus owning a house, right? Renting is easy to start, looks cheaper maybe, but you're subject to the landlord's rules, price hikes, and moving out can be a total nightmare if you're deeply settled.
That's a very good analogy, actually. And finally, data ownership and compliance questions. When your sensitive business or customer data resides on a third-party server managed by a SaaS vendor, you need absolute clarity on who owns that data, how it's protected, where it's stored geographically, and what the vendor's policies are. This is particularly crucial when dealing with regulations like GDPR in Europe or HIPAA for health data in the US. These place strict requirements on data handling and storage. You need to perform thorough due diligence on the vendor's security practices and compliance certifications, because ultimately you remain responsible for ensuring your data is handled according to the law, even if it's on their servers.
The report uses a very relatable example here. A startup adopting Authon for authentication instead of trying to build their own login system.
Oh yeah, this is a classic smart use of SaaS, especially initially. Authentication, everything from user registration, logins, password resets, multi-factor auth, managing user roles, it seems deceptively simple on the surface. But implementing it securely and robustly is notoriously complex and requires deep security expertise. It's a standard requirement for almost any application, but for most businesses, it's not their unique value proposition. So the startup, needing to move fast and focus on their core product, chose Auth, a leading authentication as a service provider. Makes total sense.
And the immediate benefit, according to the source, was pretty clear. It saved them weeks of work.
Easily weeks, probably months of highly skilled engineering effort that would have been required to build a secure, scalable, and compliant authentication system from scratch. By buying this functionality as a service, they could redirect those valuable engineering resources to building the unique features of their actual health tech product.
But then came the challenge. The report highlights the moment when pricing changed and limits were hit, switching became painful. Ouch.
And this is where the vendor lock-in really became apparent. As the startup grew and scaled, their usage of Author likely increased significantly. The pricing model or usage limits they initially signed up for might have become prohibitively expensive. Or maybe they needed features not available on their plan or from the vendor at all. At that point, because authentication is so deeply integrated into the user experience and the data flow of their application, migrating off to a different provider or attempting to build their own replacement system became a massive, costly, and painful project. The initial ease of adoption was countered by the difficulty and expense of exiting that vendor relationship later on.
That use case perfectly illustrates the strategic trade-off, doesn't it? You gain speed now, maybe save money initially, but you potentially face significant pain and cost later if the vendor relationship changes or you outgrow the service, especially if you didn't really plan for that possibility.
The textbook example, yeah. And the report's takeaway for SaaS is very direct and actionable because of this risk. Buy what doesn't define you, just know the exit plan.
So buy your HR system, buy your CRM, buy your email service, things that aren't your core business value. But don't just assume you'll use the same vendor forever. Have a plan B.
Exactly. If authentication or billing or CRM is not the core reason your customers choose you, then buying is often the fastest and most efficient path. But before you sign that contract, ask the hard questions. What happens if we need to leave? Is our data easily exportable in a standard format? Are there documented migration paths? What does the vendor termination clause actually say? Thinking about that potential future exit before you deeply commit saves immense pain down the road. Don't just buy. Buy wisely with an eye on the future.
All right, so we've covered building for your core differentiator, buying for common solved problems. What about this third path, the configure option using no-code code platforms? The report calls this enabling agility for non-developers.
Yes, this approach is fundamentally about broadening who can build software solutions within an organization. It shifts some of that creation power away from the central engineering team.
The report lists the key pros here as rapid prototyping, empowers business teams, and great for MVPs and internal tools.
Rapid prototyping is a major advantage for sure. With visual interfaces and pre-built components, someone can often take an idea for an application or workflow and build a functional version of it extremely quickly. We're talking hours or days rather than weeks or months of traditional development. This allows teams to quickly test ideas, validate concepts with actual users, and iterate based on feedback without waiting for those precious engineering cycles.
And that speed directly enables the empowers business teams aspect, right?
This is perhaps the most significant impact of no-code, low-code. People working in specific business functions, say, a sales manager needing a tool to track a specific type of deal, or an operations lead needing a simple app to manage equipment requests, they often have the deepest understanding of the problem and the ideal workflow. No-code platforms allow these domain experts to build tailored solutions themselves. They bypass the need to translate their requirements to engineers, wait for engineering availability, and go through potentially lengthy development cycles. It democratizes software creation, putting the tools directly in the hands of those who understand the problem best.
So it's about getting solutions built faster by putting the power closer to the actual problem.
Precisely. And because of that speed and empowerment, these platforms are often great for MVPs and internal tools. MVPs, minimum viable products, are all about speed to market and validation. No code excels at getting a basic functional version of a product or feature out quickly to test market fit. Internal tools, on the other hand, often have very specific niche needs for a relatively small group of users within a company. Building a full custom application for, say, a departmental dashboard or a simple approval workflow is often prohibitively expensive in terms of engineering time. And a generic SaaS tool might not fit the exact process. No-code provides a really compelling, cost-effective way to build these tailored internal solutions.
Okay, so lots of upside for speed, accessibility, and solving those kind of underserved internal needs. What are the drawbacks? The friction points for no-code, low-code. The report lists the cons as hard to scale, hidden technical debt, and limited testing and version control.
Yes, and these are the critical limitations that need to be very carefully considered. Hard to scale means that while these platforms are excellent for getting started or handling moderate usage, they often hit limitations as the number of users grows significantly, the volume or complexity of data increases, or the need for high-performance integrations becomes crucial. The underlying architecture of the platform itself might not be designed for enterprise-level loads or the fine-grained performance tuning possible with custom code, or even some robust enterprise SaaS solutions. You might simply reach a ceiling on what the platform can handle gracefully.
And hidden technical debt. That's a point the report really emphasizes, particularly because the term no code might misleadingly suggest, a lack of complexity or future problems.
It's a crucial concept. Technical debt isn't just tangled lines of code. It's anything that makes a system difficult, risky, or expensive to change, understand, or maintain over time. In no-code platforms, this can manifest as incredibly complex visual workflows that are difficult for anyone, maybe even the original creator, to understand months later. It can be workarounds implemented within the platform's limitations that create brittle logic. It can be a lack of documentation or clear structure. Just because you didn't write lines of text code doesn't mean you haven't created a complex, potentially difficult to manage system that accumulates debt in a different form. And this debt can make future modifications slow, risky, and very expensive.
So you can still build a tangled mess, it's just built with drag and drop boxes instead of text.
Exactly. And often without the mature tools and practices that traditional software engineers use to manage complexity and debt, which leads directly to limited testing and version control. Professional software development relies heavily on automated testing suites to ensure that changes don't break existing functionality, and robust version control systems like Git to track every change, manage collaboration, and revert to previous states if necessary. No-code platforms often lack these sophisticated capabilities. It can be difficult, sometimes impossible, to write automated tests for visual logic. And tracking changes or collaborating on development can be much less streamlined than with traditional code. This makes it harder to ensure quality and manage the evolution of the application reliably over time.
The report provides a use case of a logistics firm using a no-code, glow-code platform, something like Retool, to build internal tools.
Yes, and this perfectly illustrates the power of applying no code to the right problem. This logistics firm used Retool to build internal dashboards for tracking operations and approval workflows for various processes. These are essential internal functions. They help the business run smoothly, but they're typically not the logistics firm's core, unique competitive advantage. Their value comes from their logistics network and operations expertise, not from building internal dashboards.
And the impact, according to the source, was significant. No developer involvement was needed.
This is the key win here. They solved a real important business need using people within the logistics or operations teams, people who understood the workflow intimately. By leveraging the no-code platform, they didn't have to pull their highly skilled and likely very busy software engineers away from optimizing their core logistics systems, the complex routing algorithms, the supply chain management software, the things that are their differentiator. It put the solution-building capability directly in the hands of the problem havers, efficiently utilizing different skill sets within the company.
You see how that empowers non-engineers and optimizes the use of valuable engineering time. It's really about putting the right tool for building software in the hands of the right person for the job.
Precisely. And the report's takeaway for the no-code, low-code section captures this balance really well. No-code isn't for everything, but it's perfect for some things. especially when you need speed more than polish.
Speed to build, speed to iterate, speed to get a tool into someone's hands. Maybe prioritizing that over, say, enterprise-grade scalability or perfectly managed technical debt for applications that are considered low risk.
Exactly. Think of it as a powerful, specialized tool for specific jobs, getting a prototype out fast, automating a simple departmental process, creating a quick internal dashboard. It excels in these scenarios where speed and empowering non-developers are the top priorities, and where the risks associated with scalability limits or hidden technical debt are relatively contained, because the application isn't mission-critical or doesn't need to handle massive scale. It's definitely not a universal hammer for every single software problem.
Okay, we've now looked at the individual paths building with custom code, buying with SaaS, and configuring with no-code, low-code. But just knowing the pros and cons of each doesn't automatically tell you which one to choose for a specific project, does it? The report makes a really critical point here. You have to look beyond just the immediate cost or the speed of launch. It introduces this concept of the cost of ownership equation.
Yes, and this is where a purely technical evaluation really needs to morph into a strategic business decision. It's easy to compare the upfront costs, right? A custom build looks expensive initially. A SaaS subscription is an ongoing fee. And no code might seem almost free to start playing with, but that initial cost is just one piece of a much larger, longer-term puzzle.
The core question the report urges teams to ask themselves is, how much will it cost to build, run, evolve, and secure this solution? Not just now, but over 3 to 5 years.
Exactly. You absolutely have to consider the total cost across the entire expected life cycle of the software solution. Let's break down what those costs involve for each path, looking over that 3 to 5 year horizon the report suggests. For custom code, yes, the initial build cost is high, but then you have significant ongoing costs. There's maintenance, fixing bugs, keeping libraries updated. There's hosting and infrastructure management. There's security patching and monitoring that's a constant effort. And crucially, the cost of adding new features and adapting the software as your business needs inevitably evolve. All that engineering time adds up year after year. For SaaS, the initial cost is usually low, maybe some setup fees and the first subscription payment. The ongoing cost is primarily that subscription fee. It's predictable, but it can definitely increase over time with usage, feature tiers, or just general vendor price hikes. You also have a potential future cost if you need deep integrations built, which might require your own engineers, or if you eventually decide you need to replace the service due to limitations or vendor issues.
That's the cost of that potentially painful migration or rebuild we talked about. And for no-code, the initial cost is often very low, sometimes even free for basic plans. The ongoing costs might include platform subscription fees, which often scale with users or complexity. And then there's that critical hidden cost of dealing with technical debt. As the application grows, the cost of understanding it, modifying it, fixing issues, or hitting scalability limits can require significant time, either the original builder's time becoming inefficient, or eventually needing engineering involvement to refactor or rebuild parts of it. Security and maintenance responsibility for the application logic itself, not the underlying platform, can also fall to the builder, adding more potential hidden costs.
So that upfront cheapness or apparent low cost can definitely mask significant expenses down the road across all 3 paths, just in different ways.
Precisely. Maintenance, security, and the ability to adapt to changing requirements are costs that exist regardless of how the software is initially built or acquired. They just manifest differently across the 3 approaches. You really need to look at the total expenditure over that longer time frame.
The report includes a really helpful example comparison table. It visually breaks down these different dimensions: speed, flexibility, cost, across the 3 paths.
That table is a fantastic summary of the report's analysis, yeah. Let's maybe walk through a few of the key comparison points it highlights.
Okay, sounds good. The first one is initial speed. The table lists custom code as slow, SaaS as fast, and no code as, well, instant.
Yeah, this is probably the most straightforward one, and often the first thing people consider. Building something from scratch just takes significant time for design, development, testing, deployment. Adopting a pre-built SaaS tool is much faster. You're mostly configuring it to your needs. And no-code platforms are often the absolute fastest way to get a basic, functional application or workflow running, sometimes within hours or days.
Yeah.
This speed is directly related to how quickly you can start getting value from the solution or, testing a new idea.
Then there's flexibility. Custom code is high, SaaS is medium, and no code is low.
Right. This reflects how much you can tailor the software to your exact, specific requirements. Custom code offers maximum flexibility theoretically. You can build anything you can imagine, down to the smallest detail. SaaS offers medium flexibility. You can configure settings, integrate via APIs, maybe customize some workflows, but only within the vendor's defined boundaries. You're ultimately limited by their feature set and underlying architecture. No-code platforms often have the lowest flexibility. You're limited by the available pre-built components, templates, and the platform's visual logic capabilities. If you need something truly custom or particularly complex, you might find yourself hitting the platform's boundaries pretty quickly.
Okay, maintenance. Custom is high, SaaS is low, no code is variable.
Yeah, as we discussed, with custom code, your team is entirely responsible for all maintenance, bug fixes, security updates, infrastructure, everything. That's a high ongoing burden. With SaaS, the vendor handles a core software maintenance, so your internal burden is low. With no code, it's listed as variable. The platform itself is maintained by the vendor, which is low burden for you. But maintaining the application you build on it, well, that can be low for simple apps, but it becomes increasingly high and complex as the application grows and that hidden technical debt accumulates. Debugging complex visual logic or adapting convoluted workflows can become very time-consuming.
And strategic value. Custom is potentially high, SaaS is low, no code is low.
This goes right back to that differentiation point we started with. If the software embodies your unique intellectual property or competitive advantage, it has potentially high strategic value, and building it yourself with custom code is often necessary to protect and maximize that value. Standard SaaS and no-code solutions typically address common business problems that, while important, don't differentiate you competitively. They are valuable for enabling your business operations, but they aren't usually the core reason customers choose you over a competitor.
And finally, the category that really encapsulates the whole equation itself, cost over time. Custom is high, SaaS is medium, no code is hidden.
This just summarizes that total cost of ownership concept nicely. Custom code has high initial and high ongoing costs due to development, maintenance, and evolution. SaaS has a predictable, usually medium ongoing subscription cost, plus those potential future migration or integration costs. No code is listed as hidden because, while the initial cost might be very low or even free, the long-term costs are often less predictable and can be significant. Think about the time spent dealing with scaling limits, the cost of refactoring or rebuilding when the hidden debt becomes unmanageable, or platform fees that might grow unexpectedly with usage or complexity. That initial ease can create a real blind spot for substantial future expenses.
Looking at that table and understanding those different cost dimensions over time, the report's takeaway here becomes incredibly clear, doesn't it? Choose based on total cost of change, not just cost to launch.
Absolutely. This is the strategic lens you really need to apply. Don't just ask, how much does it cost to get this thing running today? Ask, how much will it cost to get this running? And then keep it running. Fix it when it breaks, add new features, integrate it with other systems, and potentially replace it 5 years from now. What happens if the business requirements change significantly? What's the cost of adapting the software in each scenario? That cost of change over time is often the most important factor, not just the initial sticker price.
So if each approach has its own set of pros and cons, and we really need to think long-term about this total cost of ownership equation, what's the prevailing wisdom? What's the recommended strategic approach for 2025, according to the report? It sounds like the future isn't choosing just one, but leveraging a hybrid approach.
Yes, the report really emphasizes that the most effective approach in the modern software landscape is rarely about relying solely on one path. The trend they identify is clearly that modern tech stacks often combine all three approaches.
Right. Why limit yourself to just one tool when you have 3 good ones for different jobs?
Exactly. Why try to force every single problem into one solution type when you can strategically leverage the specific strengths of custom code, SaaS, and no code where they are most appropriate?
Yeah.
It shouldn't be an ideological debate. It should be a pragmatic decision to use the right tool for the right job within your overall technology ecosystem. Different problems, different teams, different levels of strategic importance. They just call for different solutions.
The report gives a breakdown of what a typical modern hybrid stack might look like, showing components built with each approach.
Yeah, they structure it in a way that lines pretty well with the strengths we've been discussing. First, custom core logic and differentiators. This is where you keep the unique IP-heavy parts of your business. You build this internally because it's your competitive edge and requires maximum control. Second, SaaS for commoditized infrastructure. This covers all those common needs that pretty much every business has, but which don't really differentiate you. Things like your payment processing using Stripe instead of building your own payment gateway. Authentication using Auth instead of building login flows. CRM using Salesforce. And leveraging foundational cloud services like managed databases, AWS RDS, or Google Cloud SQL, or specific compute functions like AWS Lambda. These often have SaaS-like qualities. You use them without managing the underlying servers. And third, no code for internal enablement. This is where you empower business teams to build those internal dashboards, specific departmental workflow tools, or simple automation apps. It frees up engineering while solving those niche internal problems quickly.
So the strategic core is custom, the common utilities are bought, SaaS, and the internal quick wins are configured, no code. That feels like a logical split.
Essentially, yes. It's fundamentally about allocating your most expensive and scarce resource-skilled engineers to the problems only they can solve, the ones that create your core differentiation, and then using other tools and services much more efficiently for everything else.
The report provides a use case of a scaling health tech startup that really exemplifies this hybrid journey over time.
Oh yeah, this is a fantastic illustration of how the strategy isn't static. It evolves as the company grows and its needs change. The health tech startup in the example initially adopted a hybrid approach, mostly out of necessity for speed. They use Stripe for payment processing, that's SaaS. They use Firebase for some backend services like authentication and database. Firebase is technically a platform as a service, but it has strong SaaS characteristics, providing managed services that really speed up initial development. And they used a no-code tool for internal dashboards related to things like onboarding or patient tracking.
And the strategic why for starting this way was speed, right?
Speed to market and resource efficiency, absolutely. In the early days of a startup, proving your core value proposition is paramount. They needed to get their unique health tech features built and validated quickly. By using proven off-the-shelf platforms and SaaS for standard components like payments and authentication, their limited engineering team could focus almost exclusively on the complex, unique health tech challenges they were trying to solve, the patient data management, the specific algorithms, the things that actually define their product.
But then as the company matured and began to scale significantly, the report notes a shift. They rebuilt dashboards in React, custom code, and replaced Firebase with Postgres plus custom APIs, more custom code. Why the change?
This is where that start fast, own later principle really comes into play. As they scaled, they likely started hitting limitations with those initial solutions. The no-code dashboards might have become too slow or inflexible for more complex reporting needs. Firebase, while incredibly fast to start with, might have lacked the control, performance, or specific database features needed for enterprise-level health data management. Or perhaps the costs just became prohibitive at their new scale. At that point, the cost and effort of rebuilding those parts with custom code using a robust database like Postgres, which requires more self-management, and building custom APIs, writing their own code to handle data access and logic, maybe using frameworks like React for complex UIs, that investment became justified. They needed more control, more performance, more flexibility, and the ability to integrate these systems precisely with their growing, complex core health tech platform.
That sequence perfectly illustrates how your strategy isn't a one-time decision locked in stone. What's the right choice at launch might actually be the wrong choice once you hit significant scale.
Exactly. The decision is always contextual to your current stage, your resources, your immediate needs. But you must be prepared for that decision to change as the business evolves. Which brings us neatly to the report's takeaway here. Start fast, own later, use off-the-shelf tools to test ideas, and switch to custom when scale or control demands it.
It's a very pragmatic, iterative approach to software strategy, not a rigid doctrine.
Precisely. Use the fastest path initially to validate, learn, and gain traction. But understand that for core systems, or as you reach significant scale, you might need to migrate towards custom-built solutions to gain the necessary control, performance, or differentiation. Planning for that potential transition up front, even if it's just an awareness that it might happen, is absolutely key.
Okay, so while combining these approaches strategically is smart, the report also gives us some pretty strong warnings about common pitfalls, basically, making the wrong bet for a particular problem, which can lead to serious problems down the line. What are the red flags we should be watching out for?
Yes. The report explicitly lists 3 main types of wrong bets, or red flags, that teams commonly fall into. They're worth paying close attention to.
Okay, they are. Overbuilding for problems with existing SaaS solutions, overbuying when flexibility or control is crucial, and overusing no-code in systems that require auditability, scalability, or version control.
Let's dig into the dangers of each one. Overbuilding for problems with existing SaaS solutions is probably the most straightforward waste of resources. This happens when a team decides to build a complex internal system, say, for customer support ticketing or employee onboarding or internal project management, even though perfectly good, robust, secure, and often more affordable SaaS solutions already exist for that exact problem. The danger here is twofold. First, you waste valuable engineering time and budget that could be spent on your actual differentiating product. Second, you saddle yourself with the ongoing maintenance burden for a system that isn't core to your business value. You've just built and now have to maintain forever a non-strategic commodity function.
It's the ultimate form of reinventing the wheel, isn't it? And now you're stuck maintaining that wheel forever, pulling resources away from building your actual vehicle.
Exactly. A perfect analogy. The second red flag, overbuying when flexibility or control is crucial, is kind of the flip side. This is adopting a rigid, off-the-shelf SaaS tool for a process that is actually core to your differentiation or requires frequent, unique adaptations. For instance, if your unique sales methodology is your competitive edge, buying a rigid, standard CRM system that can't be deeply customized to match your specific process would be overbuying. You gain initial speed, perhaps, but you quickly hit the limitations we discussed under the SaaS cons. You become locked into a system that prevents you from iterating on your core differentiating process, directly hindering your ability to innovate and compete effectively. Your unique secret sauce gets forced into a generic, vendor-defined bottle.
So the very thing that makes you special gets constrained by a system designed for everyone else. Ouch.
Precisely. And the third red flag, overusing no-code in systems that require auditability, scalability, or version control, is a crucial warning about applying no-code platforms inappropriately. While they're excellent for speed and many internal tools, using no-code platforms for systems that handle high transaction volumes require rigorous tracking of every change for compliance or debugging, that's auditability, need predictable high performance under load scalability, or where collaborative development and reliable change management are essential, version control. Well, that's a major risk.
The report drives this point home with a bit of a cautionary tale. They call it the no-code to tech debt spiral.
Yes, this is a powerful example of that third red flag in action. The report describes a team that initially built what eventually became a core operations system using a no-code platform. It was fast to build, it enabled the team's initial workflows, everything seemed great.
But then the spiral began. It became mission-critical but unmaintainable, with no testability or observability. That sounds bad.
That's the classic manifestation of technical debt in a no-code context. As the business came to rely heavily on this system, it became mission-critical. But because no-code platforms often lack those robust tools for automated testing, version control, and observability, the ability to monitor the system's health, performance, and easily debug issues, the application became brittle and opaque. Any change was risky because you couldn't easily test its impact beforehand. And when something inevitably went wrong, it was incredibly difficult to diagnose and fix the problem hidden within the complex visual logic. It became a black box that everyone was afraid to touch.
And the report gives the painful punchline. Rebuilding costs twice as much as building it correctly initially would have.
A very, very expensive lesson learned. The initial speed and perceived low cost of the no-code solution masked a massive future expense and operational risk. The accumulating technical debt made the system fundamentally unmanageable, forcing a complete, costly rebuild, a cost that was significantly higher than if they had made a more appropriate strategic choice, either a robust custom build or perhaps a suitable enterprise SaaS, right from the outset.
That cautionary tale is a stark warning about the hidden cost of no-code when it's misapplied to systems that genuinely require robustness, predictability, and long-term maintainability. It might seem fast initially, but the debt can accumulate silently until it forces a crisis and a much larger expenditure down the line.
It really underscores that while no-code is powerful, it's not a panacea. Each approach, build, buy, configure, has a context where it shines and context where it is fundamentally unsuitable. Which brings us quite nicely to the takeaway from this section of the report. Each approach has an expiration date. Plan for when it comes.
Meaning, your initial choice might be the absolute right one for your current stage or problem, but you need to have the strategic awareness to anticipate when the needs of the business might outgrow that solution. And you should factor that potential future transition into your initial decision-making process.
Yes, it's all about strategic foresight. Don't just assume the solution you choose today will be the right one forever. Be mindful of the limitations of your current choice and have at least a rough idea of what transitioning to a different approach might look like down the road. That awareness is key.
So, given all this complexity, the pros and cons, the long-term costs, the potential pitfalls, how do you actually navigate this landscape? How do you make the right choice, or at least a well-informed choice, for a new software project or system? The report provides a helpful decision framework, essentially, a set of questions designed to guide your thinking process.
Yeah, these questions are really designed to help you move beyond just assumptions or, defaults. We always build things here, or we always buy sauce, and deliberately consider the most important strategic and practical factors for your specific situation.
Okay, the report lists these key questions to ask yourself and your team. First, is this core to our value proposition? Second, do we need to scale or customize it deeply? Third, how fast do we need it? Fourth, what's our team's current capacity and expertise? Practical one. Fifth, what happens if the vendor fails or prices change? That's the sauce check. And sixth, is this a temporary prototype or a long-term asset?
Right. Let's think about how these questions work together, how they interact to guide the decision. The first question, is this core to our value proposition, is arguably the most important initial filter. If the answer is a resounding yes, this software is what makes us unique or competitive, that immediately creates a strong bias towards building it yourself with custom code. You need maximum control, and you need to protect your IP.
Even if another path might seem faster or cheaper initially.
Even then, generally speaking. While speed and cost are always important, compromising on control or uniqueness for something that is truly core to your business is a strategic risk that most companies probably can't afford in the long run. The second question, do we need to scale or customize it deeply, refines this further. If you anticipate needing to handle massive future scale or require deep, specific customization that goes way beyond simple configuration options, that again pushes you away from rigid SaaS and often beyond the practical limits of no-code. It leans heavily towards custom code, or maybe a very flexible, potentially expensive enterprise-grade SaaS platform specifically designed for deep integration, though that still carries vendor risk.
How fast do we need it? Seems like the primary driver for often opting for buy sauce or configure no code, especially early on.
It is often the key factor for getting started quickly. Absolutely. If you need a solution deployed and delivering value in weeks rather than months or years, build is likely off the table for anything but the simplest functionality. So, for non-core functions, or for initial validation of an idea, speed heavily favors buy or configure. But, as the report emphasizes throughout, you can't let speed be the only factor. You have to weigh it against the long-term implications raised by all the other questions.
And what's our team's current capacity and expertise? That feels like the crucial practical reality check.
Absolutely. Strategy is great, but you have to consider what's actually feasible with the resources you have right now. If your engineering team is small, or fully allocated to other critical projects, or perhaps lacks the specific expertise needed for, say, a complex security system or a high-performance custom database, then even if build is strategically ideal on paper, it might simply not be possible in the required time frame, or at all. In that case, buy or configure might be the necessary pragmatic choice, even if it means accepting some compromises compared to the theoretical ideal. It forces you to consider your resource constraints realistically.
What happens if the vendor fails or prices change? This forces you to directly address that vendor risk and potential lock-in whenever you're seriously considering a SaaS solution.
Exactly. It pushes you to think about that exit plan we discussed earlier. How critical is this function to our daily operations? How difficult realistically would it be to replace this vendor if we had to? Can we mitigate that risk through specific contractual terms or ensuring good data export capabilities? This question is key to making a smart buy decision, not just an impulsive one based on initial features or a tempting low price.
And finally, is this a temporary prototype or a long-term asset? This seems particularly crucial for deciding if no-code is an appropriate choice.
Definitely. If the goal is to quickly test an idea, validate a workflow, or build a tool might be disposable or likely need a complete rebuild later anyway, then the speed and low initial cost of no-code make it a very strong contender. If, however, the goal is to build a mission-critical system that will be a foundational asset for the business for many years to come, that generally points away from no-code and towards build. Or perhaps a very carefully chosen, robust, and scalable SaaS solution, explicitly considering that long-term cost of change and vendor viability.
The report then helpfully simplifies this framework into a concise decision guide, sort of a rule of thumb, based on applying these questions.
Yes, it's a handy summary to keep in mind as a starting point for evaluating any new software need. First, build R for strategic IP and critical systems. Second, Buy E for common, solve problems with mature vendors. And third, no code for speed, iteration, and low-risk automation.
That seems like a really practical, memorable way to begin thinking about any new project or requirement.
It is, absolutely. But it's crucial to remember that the questions in the framework are essential for adding the necessary nuance and context. This isn't a rigid formula that just spits out a single answer every time. For example, a common problem might still require a custom build if your unique way of solving that common problem is your strategic IP. And a low-risk automation, built with no code, can absolutely become high-risk if the business unexpectedly comes to rely on it as a critical system down the line. You really need to use the questions to truly understand the context and the long-term implications for your specific situation before applying that simplified guide.
Wow, okay. We've really taken a deep dive today into this build, buy, or configure strategic question. It feels like we've unpacked a lot. We've looked at the three distinct paths, their significant pros and cons, how to think about that crucial long-term cost of ownership, the power of strategically combining approaches, and yeah, the dangers of making the wrong bet for the wrong problem.
It's definitely a complex decision space, no doubt about it, but the report provides a pretty clear, actionable framework for navigating it. Importantly, it moves the conversation from being a purely technical one, what tech should we use, to a truly strategic business discussion about resource allocation, risk management, and competitive advantage.
So what is the final word then? What's the ultimate message that this report, Build, Buy, or Configure Software Strategy in 2025, leaves us with?
The conclusion of the report really brings it all together perfectly, I think. It states quite plainly, it's not build versus buy versus click, it's all three.
So it's not about picking a single winner, is it? It's about recognizing the strengths of each tool in the toolbox and knowing when and where to apply them appropriately.
Precisely. The report emphasizes that the smartest teams in 2025 aren't rigid. They're adaptive. They don't have a single default answer. They analyze each problem based on the strategic context, the required speed, the need for control, the available resources, and the long-term cost implications. They understand when to code for control, when to buy for scale, and when to click for speed. That adaptability, that willingness to mix and match approaches intelligently across their technology stack is what allows them to move faster and build more resilient, effective systems overall.
That ability to continuously evaluate and choose the best path for the specific need and the current stage of the business, that really seems like the hallmark of effective technology strategy today.
It really is. It boils down to strategic flexibility. And that leads directly to the ultimate goal the report identifies. The goal isn't purity, sticking dogmatically to one approach. The goal is shipping value faster without compromising future flexibility.
Get great software into the hands of users quickly, whether those users are internal employees or external customers, but do it in a way that doesn't paint you into a corner later on. Avoid those pitfalls we discussed.
Exactly. Understanding these trade-offs, understanding the total cost of ownership, and having that decision framework we talked through, it empowers you. Whether you're the person ultimately making the build by configure decision, or you're contributing requirements or technical expertise to that decision, this knowledge helps you participate effectively in those critical strategic conversations and, hopefully, make better decisions about where your limited engineering time and thus significant financial and human resources are best invested. So here's maybe a final thought to chew on, building on the report's themes. Given that the report suggests thinking about cost of ownership over 3 to 5 years and acknowledges that even core systems built today might need significant evolution or partial replacement within that time frame, how does the increasing pace of AI capabilities potentially disrupt or shift this build-buy-configure equation again? Especially thinking about those commodity functions. Are there scenarios where AI could commoditize even more functions much faster than we expect, maybe making buying or configuring AI-driven services the new default for things we currently build or buy? Or conversely, could AI actually empower custom builds in entirely new ways, maybe automating some of the boilerplate? It adds another interesting layer.
That's a fascinating layer to add to this already complex decision matrix, isn't it? It really feels like the strategic landscape is constantly shifting under our feet. Definitely something worth considering as you look at your own projects and decisions. We've covered a tremendous amount in this deep dive into the crucial question of building, buying, or configuring software in 2025. Thank you so much for joining us today. We really hope this gives you a much clearer, more strategic perspective on those vital software decisions you might be facing.